All right, guys, I wanted to add these two vectors using component method. So we have 20 meters per second at 53.1 degrees above the horizontal. I'll call this one velocity vector 1. And then we have 25 meters per second at 36.9 degrees below the horizontal. I'll call this velocity vector 2. In order to add these using the component method, what that means is we're going to break each vector up into its x and y components and add those individually. So here's x, here's y. So we want to decompose our vectors along those coordinate axes. So I'll start with vector 1. To break it up, here is the x component of the vector. Here is the y component of the vector. I'm going to redraw this so we have some room. Here's the vector. This will be v1x. This will be v1y. This angle is 53.1 degrees. This is 20 meters per second. By decomposing the vectors along x and y, what that does very conveniently is give us a right triangle here. So recalling that we have SOHCAHTOA at our disposal, we can use sine, cosine, and tangent to get Vx and Vy. So directly across from the right angle is always the hypotenuse. Directly across from the given angle is the opposite side, and the only thing left is the adjacent side. From there, if I start with Vx, that's adjacent over hypotenuse, which is cosine. So this is 20 cosine of 53.1 degrees. So 20 cosine of 53.1 is 16. And for Vy, that is going to be 20 sine of 53.1 degrees. 20 sine of 53.1 is actually 16. My apologies, guys. I looked at my notes wrong. 20 cosine of 53.1 degrees is 12. All right. Always when you're adding vectors by components, guys, always double check the signs of those components. So based on our coordinate system, guys, this way is positive and this way is positive. So Vx is positive, Vy is positive. Okay, that will come in handy in a moment. Let's look at our second vector. If we break that second vector up, v2 in its x and y components, here's the x component, here's the y component. So let's redraw that. Looks like this. Here's v2x. Here is v2y. This angle here is 36.9 degrees. This value is 25 meters per second. Same idea. Because we've broken it up along x and y, we have a right triangle. So this is the hypotenuse. This is the opposite side here. And this is the adjacent side. So if we start with the x component, that is going to be 25 cosine of 36.9 degrees, giving us 20 meters per second. And Vy, that's opposite over hypotenuse, which is going to be 25 sine of 36.9 degrees. And that gives us 15 meters per second. Always double check signs. If you notice, the x component of this vector is in the positive x direction, so this is plus. And the y component is in the negative direction, so this is minus. From there, let's make a chart to stay organized. So in my chart, I will list three things. I will list my vectors, and I will list their x components, and their y components. So the two vectors we had were v1 and v2. We are looking to add them, so we will be finding the resultant. For vector 1, its x component was 12. Its y component was 16. For vector 2, its x component was 20. Its y component was minus 15. Since we are adding them, that is the same as adding down the columns. So we get here is 32 meters per second in x and 1 meter per second in y. So this becomes the x component of my resultant and the y component of my resultant. In order to get the resultant as a magnitude and direction, I need to draw what that looks like. So we have Rx, which is 32, Ry, which is 1, and then we have R, and we have some angle. So I need to find R and theta here. R, we'll use Pythagorean theorem, so that is the square root of 32 squared plus 1 squared, giving us about 32.01 meters per second. And theta, we use tangent inverse. It's 1 over 32. Giving us 1.79 degrees north of east. So our magnitude and direction written together is 32.01 meters per second at an angle of 1.79 degrees north of east. I hope this is helpful, guys. Thanks. Have a great day.